So the next part is transport layer protocols. The transport layer protocol is represented by two protocols. You have the TCP protocol and the UDP protocol. So let's see the TCP protocol, Transmission Control Protocol. It provides full transport layer services to the application. So what does TCP do? It provides full transport layer services to the application. It is a connection oriented protocol, means the connection established between both the ends of the transmission. So TCP is a connection oriented protocol, means there is a connection which is established at both the ends of the transmission. TCP generates a virtual circuit between sender and the receiver for the duration of a transmission. So the features of TCP. Stream data transfer. TCP itself segments the data and forward to the IP in the form of continuous stream of bytes. Reliability. TCP assigns a sequence number to each byte transmitted and expects a positive acknowledgement from the receiving TCP. Flow control. It uses window mechanisms, so receiving TCP sends an acknowledgement back to the sender initiating the bytes it can receive without overflowing its internal buffer. Multiplexing is the process of accepting the data from different applications and forwarding to the different applications on different computers. At the receiving end, the data is forwarded to the correct applications. This process is called as demultiplexing. So we already saw multiplexing, demultiplexing, flow control, reliability and stream data transfer. Logical connections. The combinations of sockets, sequence numbers and window size is called a logical connection. Each connection is identified by the pair of sockets used by sending and receiving processes. Full duplex. TCP provides full duplex service. To achieve full duplex service, each TCP should have sending and receiving buffers so that the segments can flow in both the directions. TCP is a connection-oriented protocol. Suppose the process A wants to send and receive the data from process B. The following steps occur. Establish a connection between two TCPs. Data is exchanged in both the directions and the connection is terminated. Next is the UDP, User Datagram Protocol. So user datagram protocol is a connectionless protocol. TCP is a connection oriented protocol. UDP is a connectionless protocol. Simple protocol that provides non-sequence transport functionality. This type of protocol is used when reliability and security are less important than speed and size. It is an end-to-end transport level protocol that adds transport level addresses, checksum, error control and length information to the data from the upper layer. So these are the functions of the UDP. The packet produced by UDP protocol is known as a user datagram. So this is an important question, can be asked for 2 marks in the internal assessment. Difference between TCP and UDP. So TCP establishes a virtual circuit before transmitting the data. UDP transmits the data directly to the destination computer without verifying whether the receiver is ready to receive or not. Connection type, it is connection oriented. This is connectionless protocol. Speed, TCP is slow, UDP is high. Reliability, TCP, it is a reliable protocol. UDP is an unreliable protocol. Header size 20 bytes, 8 bytes. Acknowledgement, it awaits for the acknowledgement of data and has ability to resend the lost packet. So because it is waiting for the acknowledgement of data, therefore we say it is a more reliable protocol. Because always a connection oriented protocols are more reliable because they are forming a connection. So when a packet is sent, till the destination machine does not reach till the packet does not reach the destination machine, the protocol will be there. So it is a more reliable protocol. So it will wait for the destination machine to send an acknowledgement. Here it neither takes the acknowledgement nor it transmits the damaged frame. So in connectionless protocol, Once the data packet is sent, it would not wait for the acknowledgement by the destination machine. So we say it is not reliable. TCP is reliable. Why? Because it will wait for the acknowledgement to be sent by the destination machine. So we say TCP is more reliable. Why? Because it is waiting for the acknowledgement of data by the destination machine, and also it has the ability to resend the lost packets. If any packet is lost, there is no message received from the packet, then what it will do, it will resend that packet. Here resending mechanism is not there, neither acknowledgement mechanism is there. UDP datagram format, header size is 8 bytes, source support address is 16 bits, destination port address is 16 bits. So source port address is also 16, destination is also 16. So total length is 16 bits, checksum is 16 bits. TCP segment format. So source port address 16 bit, destination port address 16 bits, sequence number 32 bits, acknowledgement number 32 bits, and the header size is 20 bytes. The checksum here is 16 bits, window size is 16 bits, and urgent pointer is also 16 bits. TCP segment format flags, URG. So there are different flags which are there in the TCP segment format. So here you can see these are what? These are the flags in the TCP segment format. So URG, the URG field indicates that the data in a segment is urgent. ACK, when set, it validates the acknowledgement number. PSH informs the sender that higher throughput is needed. So if possible, data must be pushed with higher throughput. RST used to reset the TCP connection when there is any confusion occur in the sequence number. SYN used to synchronize the sequence numbers in 3 types of segments: connection request, connection confirmation, and confirmation acknowledgement. FIN used to inform the receiving TCP module that the sender has finished sending data. It is used in connection termination in 3 types of segments: termination request, termination confirmation, and acknowledgement of termination confirmation. So these are the various functions of the different flags of TCP segment format. This is also important. So this was all about TCP and UDP.